Good morning. Good morning. Welcome, everyone. My name is Meryl Witteveen. I'm a product director at C3 IoT. Just a show of hands as a little warm-up. Who's familiar with C3 IoT? All right, about 2, 3, 4%. Let's make that 100 at the end of this session. At C3 IoT, we've been involved over the last 8 years to build a platform as a service to design, build, and operate AI and IoT applications. Today, I would like to describe the journey that we've taken together with our customers and give you a sneak peek of a new product that we've been working on to truly bring C3's capabilities to the hands of individual data scientists and developers. So let's have a look. When we talk about what we do at C3 IoT, we truly believe it's AI at enterprise scale. Now, today, it's a very interesting point in time. There's a convergence taking place of 4 IT phenomena. The first is cloud computing. You're all here, so I don't think I need to elaborate on that anymore. And the second is AI and machine learning, or maybe better, the rebirth or reemergence of AI and machine learning. Faster computers make it possible to make calculations and predictions that we weren't able to do before. Next is IoT. And the way we view IoT is the sensoring of an entire value chain. And for instance, take the value chain of the electricity grid. It is sensored all the way from a tiny little pump in a generation plant to the switch in your home, or the sensor in your home, which tells you whether a light switch is turned on or turned off. And with that information, you get a really powerful view of the overall value chain, and that can really put things in perspective. And then last is big data. Now, big data has been around for a while, and the way we view big data is not only the volume of data, but truly using all the data that is available to you, so not just the data in your databases. Now, one of the implications of that is that you no longer have to worry about your one-on-one statistics scores. There's no more sampling bias, which is a big advantage. But what's much more exciting about this is that this true big data, or all the data that is available to you, can really give you a very precise overview of everything that is going on in your organization at any point in time. So to recap, so the big data gives you that overview. Now, imagine if these 4 vectors converge into one seamless experience. That would truly change the way you do business. And that is what we call a digital transformation. At C3, we enable companies to go through this digital transformation and gain significant social and economic benefits. We've done this for companies in the healthcare space, in the digital or in the discrete manufacturing space, in retail, you name it. And what we allow them to do is to truly design, build, and operate AI and IoT applications. Let's take a look at a couple of examples. So a digital transformation is different in a particular industry. And in discrete manufacturing, what a digital transformation often means is predictive maintenance. And the way we view predictive maintenance and what we mean with that is that you can truly understand the state of any asset in your factory or in your plant at any point in time. And with state, I just don't mean is it turned on or off, but also who operated it last? What were the notes that this operator took? What was the last order that was fulfilled? And the goal of knowing all these factors and putting all this data together in a unified federated image is to predict whether this asset will fail in the next month, and that you can get to that asset to maintain it or to take adequate measures before it's too late. So before your plant shuts down, you want to be able to take measures. Now, C3 has done a bunch of very successful predictive maintenance applications. We've rolled these applications out for different things. So for instance, for rotating equipment, like water pumps, but also for network topologies. And with network topology, I mean the electricity grid. We can forecast whether a certain part of the electricity grid is likely to fail over the next 30 days, and a maintenance crew can take action that not a certain part of a city will actually be in the dark for a couple of days, a couple of hours. We're right now in the process of rolling out a predictive maintenance application for the US Air Force to predict system failures or subsystem failures in their F-16s and their E3 AWACS, which are the planes with a funny dish on the top. And we've also done a lighter version for human beings. And with all of these applications, what really is important to note is that we can roll out these applications, or our customers can roll out these applications in 6 to 12 weeks. And the machine learning algorithms are precise 70, 80, or 90%. And it's deployed at scale throughout the entire organization. So everybody in the organization has access to it. Now, the next interesting field is the digital oil field. And we've got several customers in this area. And some are named, some are unnamed. But one of our key customers is Origin Energy. They're an energy company in Australia. And we started out with them on a project to forecast equipment failures in their oil wells. So they have 3,000 wells, and each well has a pump rolling through. And what we did for them is we looked at what happens when an oil well or when an oil pump fails, and what do you have to replace to prolong the duration that your pump can keep pumping. And what we saw is that within a matter of weeks, we were able to prolong the duration of their equipment by a significant amount of time. And the journey we took with Origin is very interesting. We started out with a little trial, and it turned into this application that I just described, predicting failures and prolonging the duration of their equipment. And it is now being rolled out to be a platform case. And what we mean with that is that Origin now has their own developers and data scientists developing applications for their specific use cases on the C3 IoT platform. And their goal is truly to build 2 to 3 applications every 6 months to really prolong the duration of their equipment, and also to forecast other things, like, will this well, when I drill in the ground, before I drill in the ground, will it produce a lot of oil or will it not? There's no point in drilling in a well when it's not going to produce high levels of oil. So they've developed all these kinds of applications. Going a little bit back to our original roots is we started in the smart grid. And one of our big customers in this area is Enel. And Enel is an Italian utility company. They're almost the largest utility company in the world, I think with the exception of the state grid in China. They're active in over 40 countries, and they have 60 million customers, or over 60 million customers. So it's a very, very big company. And they rolled out the C3 platform, and the current data size that is on the C3 platform is approaching 1 petabyte of data. And it increases by 300 gigabytes every single day. Now, what we do with Enel, and what Enel is currently doing, is we make over 8 million predictions each day, ranging from, will a certain smart meter fail? Is somebody stealing energy from my network? Is this customer likely to churn? And will this certain piece of network of my electricity grid fail over the next 30 days? So I can send someone there to fix it early. And it's really what we know of the largest IoT deployment worldwide. Now, I won't dive too deep into smart cities because we've got a lot of other interesting materials to cover, but we're seeing some good traction going on here, and it doesn't take a lot of imagination to understand the kind of things that you can solve in smart cities using our platform. I briefly mentioned earlier predictive maintenance for human beings, or a lighter version of human beings. And what you see today is that a lot of healthcare companies use rules-based predictions to forecast whether a person, or to put a person on a scale, whether they're likely to develop diabetes or not. For instance, if your BMI is above a certain number, if your glucose levels are above a certain number, and if your blood pressure is above a certain number, you're placed in a certain risk category. Now, using machine learning, you can get much more accurate predictions. So what you can do on our platform is to ingest data ranging from pharmacology reports to clinical reports to CAT scans to a much more detailed picture. And using machine learning, we can forecast a lot more accurately whether someone will actually predict diabetes. So what this, we were contacted by a very large healthcare company, and they have over 125 million patients. Just to put it in perspective, that's larger than the population of Germany or the UK. And what they did is they wanted to forecast whether a person is likely to develop an opioid addiction, a very current topic. And what they did is they loaded all the data they had. So they loaded patient data, they loaded hospital data, they loaded pharmacology data. They loaded that all in our platform in 9 weeks. And they were able to predict with a 78 precision rate whether that person was likely or would be likely to develop an opioid prediction or addiction. And they had been trying to do that themselves for 2 years by cobbling together lots of different technologies. Now, an obvious next candidate to use the C3 IoT platform is CRM. And C3 IoT doesn't just let you connect to your standard CRM databases, but it lets you connect, for instance, also your ERP systems. So you can truly forecast, or you can truly let customers know whether products will arrive in time or whether they won't arrive in time. So this is really taking CRM to the next level. Autonomous vehicles. I won't go into too much detail of this one either, but where we're from in the Bay Area, you see them driving around all the time. And again, this is a very, very good area where you could apply the C3 IoT platform. We rolled out a predictive maintenance application for the US Air Force for their F-16s and their E3 AWACS. And what we see is after we announced that, we have a lot of inquiries from different large aerospace companies that want to truly get the economic benefits that we offer. What we are able to do is, for instance, when a plane is still in the air, forecast whether a certain subsystem will need maintenance as soon as the plane is on the ground, so they can plan it right at that time. And the economic benefits of being able to maintain these planes, knowing what has to be done in advance, is tremendous. And then there's supply chain optimization. And with supply chain optimization, we've made this into a stochastic inventory optimization model. And what we mean with that is, can I forecast the ideal level of inventory that I need to hold in my factory or in my plant to make sure I don't run out of inventory, yet at the same time, I reduce my costs? So we developed this application together with a very big discrete manufacturer in the US. They have over $40 billion of revenue, and they hold about $6 billion of inventory. And what we did is we started out quite small. We took one of their machines, which consisted of 4,500 individual pieces, for one factory. And building this model using the C3 IoT platform, we were able to reduce their inventory costs by 30 to 50%. And just to put that in perspective, their original goal was to reduce it by 1%. So We're now in the process of rolling this out worldwide, and it's tremendous economic benefits for them. Now, hopefully this gives you a good idea of the kind of projects that we do at C3 IoT and the way our platform has matured over the last few years. And before we dive into the new product that we're announcing today, I would like to take a little bit of a technical detour and show you why we can do this all in a matter of 6 to 12 weeks versus months or years that is currently the case for many other companies. And to do that, I would like to introduce you to Riley Siebel. He is a software architect at C3 IoT. Riley, come on up.
Thanks, Meryl. So you've been given some idea of the kinds of applications that the C3 IoT platform is well suited to building. And one of the things that we kept hitting was we do these in 6 to 12 weeks, not a year to 2 years. So there's some reasons why that works, and I want to show you why. OK, so you're going to build a complicated IoT, AI, big data application that runs in the cloud. You're going to need to stitch some stuff together, right? You're going to need one of everything, at least. You need a relational database. You need some non-relational databases. You need several queuing systems. You need a file storage, maybe a separate distributed file storage. You need some data federation layer. You need stream processing, batch processing, MapReduce. There's so many things, even I don't know about all of them, but you're going to have to get one of all of them. So fine, you go to the open source Hadoop stack, you pick your favorite, you hire an expert in each of those things, and then you try to make them all work together. Of course, none of them were written by the same person with the same philosophy or with the same input and output structure. So as you get these things to all talk to each other directly, it just gets really hard. And every time you add a new component, because, oh, by the way, now I want to add some new feature to my application 6 months later, I have to make that new component talk to all the other components I had before. And then 6 months later, you want to add one new feature, and now I need to add pig or whatever it is, and that needs to talk to all the things that I've previously added. So you get to a place where you just cannot keep adding features because the cost of adding the next thing is just so huge. So if you have n components, this looks like an n to the n problem, right? And those kind of problems do not scale. So that is not what we did. We took a holistic approach that we were going to need all these things because our vision was to build these types of applications from the beginning. And instead, we built a single abstraction layer we call the C3 type system, which all the infrastructure components use to talk to each other. So there's one layer that all infrastructure components use to speak to each other, whether they're databases, whether they're queues, whether they're elastic scaling algorithms, bidding algorithms, anything that you've got going, they all use the C3 type system. Now, not only do the infrastructure components use the C3 type system, but also the applications all speak to the infrastructure using the C3 type system. And also all of your developers use the C3 type system. So data scientists don't write SQL. Application developers don't write SQL. Everybody just writes type system. One thing that's really nice is, fine, if you want to throw away Oracle because you made a good decision, and you want to switch it to Postgres, great. Your application will keep running. No application has any knowledge of any infrastructure component, and no infrastructure component has any knowledge of any other infrastructure component. So this is sort of the fundamental difference between C3 platform and other platforms. You can stitch together one of everything that AWS offers, and some things AWS doesn't offer, and build an application. It's possible. People have done it. We did it, but I would recommend not doing it again because we've spent the last 7 years making it work. So in the past, in order to get access to the C3 IoT platform, people were using command line tools, which we distributed, and text editors and IDEs. Today, we're really excited to announce a new product, which we hope will get the C3 IoT platform into the hands of a lot more developers, data scientists, and product managers. And I'd like to welcome Meryl back up on stage to help me announce C3 Orion.
Thanks, Riley. So what C3 Orion does, it enables developers, and data scientists to build, to operate AI and IoT applications all in one web interface. And in that same interface, we offer a whole integrated learning solution, including documentation, tutorials, and more. So let's take a look in a little more details. We build, we operate AI and IoT applications, and we offer these learning solutions. So for building, what we've done is we have integrated a full suite of development tools, an end-to-end suite.
These visual tools allow you to do everything from designing a data model, doing time series transformation, building machine learning pipelines, and putting a UI on top of everything.
Yet at the same time, we know that not everybody wants to use visual tools. So we've also made the IDEs and command line tools very well integrated.
They're downloadable right from inside the UI. So if you want to use Eclipse, you want to use Atom, you want to use the terminal, that's fine. Everything can work together seamlessly.
And at any point in time, you can switch between one and the other.
All the tools automatically write code to GitHub that looks like code a developer would write. That means you can have teams where some people are using the visual tools, some people are using the IDEs, and you can seamlessly switch back and forth between them.
Now, on the operations side, what we allow you to do is we offer source control, DevOps, and environment monitoring.
It's not simply enough to build an application, change something in the UI, and have that be the production application. At a large enterprise, you need to have some sort of release management. You need to have some sort of source code management. You need CI. And so all of that is integrated right in the tool to allow you to manage the full development process.
And we've also integrated a very good tool to manage all your AI and ML models.
Once you've built a machine learning model, it tends to drift and lose its capabilities. And you might have several different versions of machine learning models that someone's developing a new one or even the next new one after that, and you want to have a way to decide to switch between models in production without worrying that something's going to stop working or break.
Now, to make sure that you can start developing, or your developers and data scientists can develop quickly, there's a very fast learning curve. And we've integrated tutorials, documentation, and support all in one interface.
Yeah. The same comments that come out of the code are represented in a nice UI as documentation. Same thing with tutorials, and the same thing with an integrated suite of classes that you can take online.
Now, this sounds all very nice, but let's actually have a look.
Yeah.
So what we've done for this demo is we've developed an application to forecast light bulb failures. Simple predictive maintenance application, but what we'll do during this demo is we'll show you how to build it. So let's take an actual look.
Can you log in? I don't have your fingerprints.
So the application that we created to predict light bulb failures uses machine learning, it uses analytics, and we've ingested over 3 million rows of data. What it allows me to do is it allows me to see where my light bulbs are located, and it allows me to make sure I keep a right inventory of my light bulbs.
So let's take a look at the final application, which we're going to build, so you can get a little bit of context.
As you can see, everything is live. So here on the left, we have a simple filter panel. And I can filter on manufacturer, I can filter on bulb type. And the rest of my application consists of 3 UI components. The middle one, as you can see, is a simple map indicating all the light bulbs that I have, either in green or in red. Green means there's not really a big risk of failure. Red means the risk of failure is about 50%. On the top, we have a graph showing the number of light bulbs I have by risk failure. So we see there are about 18 light bulbs in the most left category that have a failure rate between 10 and 20%. And if we scroll further down, there's a graph showing all the light bulbs I have by risk score. So let's take a look how we actually built this.
Right. So we built this tool using the C3 Orion suite of visual tools that we're demonstrating today. Here what I've done is I got a login, and I entered my GitHub credentials so that everything I do through this tool can be written to my own GitHub branch. I'm actually in Meryl's application now, and I'm in her own personal instance of this application. So everyone gets their own copy of the application. Everything they do gets written to a GitHub branch.
So this application, it took us about an hour to build it, so just for your reference. So we've done a couple of things prior to this demo. So building this application, the things I have to do is I want to create a data model by creating these C3 types that Riley just mentioned earlier. I need to integrate and possibly explore the data that I have from my light bulb. Then we analyze time series. We develop a machine learning model. And last but not least, we develop the UI.
So the first thing that you want to do when you're building a big data, AI, and IoT application is build a data model. Let's take a look at the tool that we use to do that. This is called C3 Type Designer, and it allows you to build your types. In this application, there are a few key types that were built and serve the application. The first major one is smart bulb. Pretty simple. It represents a smart light bulb. This type has several fields. Down here, you can see the list of fields that are on this type. They all have themselves a type. So the first one you can see here is a field called bulb events. It's an array of smart bulb event, which is another object in our data model. You'll notice there's no reference here to any sort of persistence. I don't talk about columns or key spaces or anything like that. This is just a type, and as an application developer or a data scientist, I sort of don't care where it's stored, and I don't have to know. If I want to start controlling that stuff, I can jump over into the Advanced tab and say I want this to be in Cassandra, I want this to be in Dynamo, whatever it is. In fact, some of the fields on this type are stored in Cassandra, and some of them are stored in Postgres. The second major type is a smart bulb event. A smart bulb event represents a time-stamped occurrence. Okay? For example, in this application, we have lightning strikes. Those tend to be predictive of smart bulbs stopping working. And switching events. So someone switches a light bulb on, someone switches a light bulb off. Each of those becomes an instance of a smart bulb event. We also have smart bulb measurements. A smart bulb measurement is a type that represents a continuous stream of measurement data. In this case, we're mostly measuring power output and brightness, or power consumption and light output, right? Those are the two things we're measuring that are sort of continuous time series. We also have a type called a smart bulb prediction. A smart bulb prediction is the output of our machine learning model. So we produce a time series of predictions. So for every day, we produce a prediction for every light bulb. And the prediction is basically a double representing the probability that this light bulb is going to fail on that day. So that's the data model that we are going to use for this simple application.
So now that we have created our data model, it's time to load some data. And C3 uses an abstraction layer to load data, which consists of two additional types. Canonical types, which ingest the data as it comes in, and it has that format, and transform types, which transform the data to the actual data model type. So Riley's showing you here a transform type, which as you can see the relationship in the data model here.
The transformation is not code, right? The transformation is expressions. That means that the system is able to know when a piece of data arrives, what parts of the data model are about to change, which means that if you have dependencies on those parts of the data model, for example, as inputs to a machine learning algorithm, we can say, oh, we need to rerun this prediction for this one light bulb because data arrived. So now that we loaded the data, we can check out the data load process.
Yes. So for this demo, we preloaded some data, but it's pretty straightforward. You just essentially drag your files into this visual tool. And what the C3 platform does automatically is it automatically processes and batches these data files. So for instance, you see that we loaded 3 files here. The first one was in one batch, the second one in 338, and the third one in 78. And not only can I monitor the data load, but I can also explore the data that I have loaded. So if we go to Data Explorer and we look up the smart bulb type that we just created and that we just loaded the data in, I can see the number of bulbs I have and all the fields associated with it. So we see here the ID, we see here the latitude, the longitude, the bulb type, for instance, is it an LED or is it something else, and the manufacturer, so GE or Philips or Bell, what we have right here.
I'll just comment that the only reason we're using files is because we have 6 years of historical data that we're going to use to train our machine learning model in a later step, and I didn't buy 100 light bulbs 6 years ago. So if I had done that, we could have used real IoT data. So we built a data model. We loaded some data into that data model. The next thing we need to do is we want to define some time series transformations, and we're going to use those time series as signals for our machine learning classification that we do. So here we have a tool for designing time series transformations. We've built several simple ones on the type smart bulb, and I'll just show you a few of them. You'll also notice, again, there's no code here. So the transformation to produce a time series which represents the average power of a smart bulb is that. Take the average of the normalized data, the power field of the normalized data. Why 2 averages? We have to aggregate over space and over time. If you come up to me later, I can go deeper on that one. But let's chart one of these things. So let's look at smart bulb 1 from January 1st, 2012 to January 1st, 2013. And let's do it at a day interval. Seems fine. There's our data, right? Now you'll note that this, again, has no code in it. So there's no reference of time. There's no loops. There's no nothing. So I can change my time interval. I can change at a monthly interval. There's the data now represented 1 point per month or whatever I want. So we compose these time series transformations into more and more complex time series transformations until we get to useful signals to do machine learning on. In particular, you can see that this average power transformation is used in a power consumption transformation and a standard deviation in wattage over the previous week. I'm going to show you a few more important ones. So eventually, the thing we want to predict is this thing defective, right? So how do we define is defective? Is defective is defined as the sum of, evaluated at every hour, is the average power 1 or not 0, and is the switched status 1. Sorry, the other way. Is the average lumens 0, and is the switched status 1? So is it not producing light and switched on? Then it must be defective. This object is evaluated in the same way. And there's one more I want to show you because we don't want to predict is it defective now. We want to predict is it defective in the future. So we have a transformation on top of this, which tells you will it fail in the next month? Will it fail? In fact, this is actually will it fail in the next 30 days. This says take the is defective signal, project over the next 30 days, and take the maximum. So if you have any 1s, the maximum is going to be 1. So 1 is true. So if it will fail in the next 30 days, then this signal is true today. So this is actually going to be our label for our machine learning classification. Great. So we defined a bunch of these transformations until we got to interesting signals to do machine learning. Now we want to do some machine learning. So here is a visual drag and drop interface for building machine learning pipelines that we call Ex Machina. I'll just give you a brief overview of the tool, and then I'll jump into this particular pipeline. You can pull data from all kinds of different places. We prefer that you pull it from the C3 platform. But if you have some data in your own HDFS instance, in HANA, in a CSV file, I guess, you can use any of those. You can do all sorts of analyses on top of that data. You can build your own complex expressions involving if-then operations, logic, transformations, mathematical operators. You can prepare the data by writing your own Scala code here, or whatever it is that you want to do, mean, shift, normalize, all kinds of stuff. And there's a bunch of pre-built machine learning algorithms, including, I'll just pick a few, random forest, PCA, linear regression, k-means. So you can play with these and try to figure out which particular algorithm is going to be the best as the predictor for your problem. Remember, in this case, we're trying to determine, will these light bulbs fail? Which ones will fail? So we're going to produce a prediction for every light bulb, use the aggregate information to, for example, buy the right number of light bulbs for next month. So let's take a look at this particular pipeline. So we're talking about smart bulbs. We're going to evaluate some time series transformations on these, right? So we played around with this for a little while, and we found that the useful signals that are predictive of failure are, what's the duration that it's been on in hours? How many times has it been turned on or off in the previous week? And has it ever failed? So those are the three signals that are relevant for predicting the label, which is, will it fail next month? So we evaluate those, and we evaluate those for 6 years at a daily interval, meaning we produce a time series point for every day for 6 years for every light bulb, and now that's our matrix we're going to be using for training. Now I split the data set. I take some of it to do the training, some of it to do the validation. In this case, I decided to do 70%. I flatten the time series, not too important. Then I train a model. So this node here is training a logistic regression model. Finally, I want to use that to do some predictions over the 6 years to evaluate how good my model was. And we'll just check it out. It takes about 5 minutes to run for all 100 light bulbs over 6 years, so I'll just do it for 10. All right, there we go. So here's a histogram of predictions over the last 6 years for these 10 light bulbs. You can see that most of the time, they're not failing. And some of them have a very high probability of failure. And in the middle, we have kind of a distribution. You can also look at the data that was used to generate this prediction, right? So here are the individual signals. Will it fail in the next month? How many times did it get switched on or off? Has it ever failed? It looks like just some of them ever failed. And so you can also do some other correlation analysis here to kind of explore how your model's doing. And once you're kind of happy with it, you can push the results of your prediction back into C3. And so the next thing you want to do, now that you've built a data model, loaded the data into your data model, built some time series transformations, and trained a machine learning model and used it to predict the future, is to build a UI, or what we call an application.
So we've developed a very simple tool to show your outcomes of all the machine learning that you did. And it's very simple to create a UI like this. So let's take a look. In this case, we've created already some components, but let's modify some of these components. And let's start by modifying the top one. The top one was the histogram. It will show up in a couple of seconds. And it had 10 bins. Now let's say I want to create 5 bins instead. All I do is I simply select the components and I make this adjustment at the bottom where it says the number of bins. And I go to 5 and we do it twice. And it will recalculate the number of bins that you want to display on this application. There we go.
So now instead of showing the distribution in 10 chunks, we're showing the distribution of failure in 5 chunks.
Now let's say I want to add an additional component at the bottom. What I do is I simply click the plus sign, and a number of components show up that we've pre-created for you so that you can use out of the box. So let's say I want to add an additional grid. And I simply drag the grid into my interface. And let's say I want to show in this grid the predictions, the bulb ID, and the latitude and longitude. So I simply select these items that I want to display, and I click Save, afterwards. And there it is. So what we did is we developed a data model. We loaded data into our data model. We analyzed time series. We developed a machine learning model. And we ended by simply creating a UI, all in under an hour.
So you've built an application, but as I said before, that's not enough. You're going to want to collaborate with your peers. You're going to want to manage this thing in production. If you're a large enterprise, you're going to have some sort of release process that you need to manage. So let's see how all of that is done. Oh, just as an aside, you'll note some of this data is coming. This is coming from 3 different databases, but I don't care. So the first thing you have is source code management. So one thing we mentioned before is that everything we're doing here is just writing code. It either is JSON metadata kind of configuration or really code or expressions. And I have here the ability to see what's going on in my branch, which was automatically created for me, and create pull requests to master, rebase on master, whatever it is that I'm going to need to do. So great. I push code to master. What should happen next? CI should take over, right? We should get all of our tests to run. We should get builds created. We should have test reports for those builds. And then we're going to eventually want to deploy something somewhere. So the first thing is the builds. So here we have, I don't tend to write tests that fail for demos. So we have 100% test passing here. And over time, we can see how this package has been doing over time. The most recent build had 11 tests. They all passed. Good job. Once we've built and tested this thing, the deployable artifact is produced, and we want to go maybe deploy it. So here we can see all the builds. We've so far built 152, sometimes several of them per day, if there have been several commits coming in per day. Each one of these has test results associated with it, and we can just deploy it to the staging environment right here. Oops. Let's not do that. OK. And we can deploy it to stage right here. We also can manage multi-environment deployment pipelines. So in my organization, you have to deploy to stage. It gets pre-validated. You have to deploy to QA. It gets full white-gloved, and then it goes to production. You can manage that pipeline through this tool. So if I had something at staging, I could push it to production here, right? And certain users can be given that permissions versus not given those permissions. So that allows me to build the application and then manage sort of the release process and test process of it without sort of getting into the code. But again, all of this is doable from command line. We're just showing you the pretty version.
So once my application is up in production, I also want to manage my environments. So we've got a couple of tools for that integrated in this experience as well. So the first one is I can show the queues that are currently happening. And
you'll notice there's not too much happening here today.
The next is environment performance. Let's take a look. So what I can see here is I've got 6 instances running at the moment, 2 masters and 4 workers. And I can just adjust that in this tool right here. I can adjust the number of nodes, and I can turn on and off autoscaling.
When I turn autoscaling on, if a new node comes up, it comes up ready with everything installed, all the Python libraries that you've declared as being necessary for some of your machine learning, and it's all kind of right here, ready to go.
So you notice on the top there are some other tools. For instance, we can write our cron jobs. We can do that right here. We can also view them. And there are some more alerts admin and user admin tools that we have.
So I mentioned that this is all code, and I hope that you saw some of those grids that we showed before, because I like to use this tool, which is the C3 console, we call it, which is a JavaScript-based interface for communicating with a running server. So here I'm now communicating with my cluster, Merrill's particular instance running on that cluster, which is fundamentally multi-tenant. There are like 12 people giving demos on this cluster right now. And we can just interact with it. So I mentioned that you use type system, right? So this smart bulb thing is added to the global scope as essentially a JavaScript prototype when I'm in JavaScript world. When I'm in Python, there's also a thing called smart bulb. That's an instance of a Python class. They both get their definitions from the type that I declared. And same thing in Java, same thing in R. So any function written in any language can be called from any other language. I mentioned that. This fetch one happens to essentially be written in Java bytecode because it's fast. So since we wrote fetch in Java bytecode, it's super fast, and you don't have to rewrite that in some other language to call it from Python. So here I'll just call smartbulb.fetch. Here are all our smart bulbs. Right? Again, some of this data is coming from Postgres. Some of this data is coming from Cassandra. I sort of don't care. I'm just dealing with the types. I've mentioned that types are the thing that makes us different from other organizations here at AWS, and I think it's really fundamentally true.
So what we've done so far is we built our smart bulb application, and we showed you how you can operate it. Now, the last thing is we would like to show you is our integrated learning environment. And here, we're looking at our documentation. What we've done is we're exposing all of the documentation that we have. For instance, we've got a whole set of tutorials. So let's take a look at how you would write a MapReduce tutorial. The documentation is all searchable, so you can just search for anything that you would like to find at any point in time. And it comes up like this. We also have a Stack Overflow-like community that you can access from here. And this is really your way to leverage the C3 developer community. There are hundreds of developers active on this community right now. And it's all available for you to use. And last but not least, we have a Learn portal, which includes over 8 hours of lectures by C3 developers and experts to really get you up to speed and to get you to use the best practices to be as efficient as you can. And you can really watch these lectures at your own pace, at your own time, whenever it suits you. And you can watch them over and over again.
I also just want to comment, because I think it's cool, that all the fields and all the functions on all the types, because they're declared in this type system, automatically become documentation. So for example, the documentation on the type is rather good. And this just comes right out of the code on this type. And similarly for everything else, you can just get full documentation of all the data objects automatically right here. So we've showed you Orion. Orion is a visual tool for building and operating AI and IoT applications at enterprise scale with integrated learning to help you get up to speed building applications quickly. So what are we asking you to do today? We're asking you to get free beta access, okay? The beta starts in January. It's the beta of the visual tools, just to be clear. The platform has been in production, people using it all the time, but the visual tools. So in early 2018, we're going to be starting a 3-month beta where you can get free access to Orion, the C3 IoT platform, and all of the AWS components that implies, right? So RDS, DynamoDB, AWS IoT, Kinesis, SQS. The list kind of goes on and on forever and includes most of AWS components. So we want you to go to orion.c3iot.com. We want you to apply for the beta. Winning teams, winning teams.
It's OK, I got it.
You got it. Winning teams have lots of data, OK? Winning teams have an interesting idea that will matter, and hopefully are not in one of the industries that we've sort of already nailed. So if you make parts for cars and you race cars and you want to be the fastest around the track by tuning your whatever, perfect, right? That is the kind of thing that we're looking for, and we want 6 to 10 teams. So come to orion.c3iot.com, apply to join the beta, get free access and access to me to help you kind of build this thing for like 3 months, and we're really, really excited to see what you guys will all build. Thank you so much.
And on a little side note, if you're really interested, we're also hiring.
Yeah. Oh, and come visit us in the Expo Center. We have 4, we're not booths. If you find someone serving espresso, that's where we are. There are 4 booths around the Expo Center, and we would love to talk to you about C3 IoT.
Thank you.